Let's begin linked list now. In linked list you will have many boxes here of this form, and each box will be connected with the next box. Okay, so in linked list you will have two parts here, info part and the next part. What will info part have? That will have the information here, means number or alphabet or anything. Okay, and that next will have a address part. In this address it will be connected to the next block. See, each box has an address here, location. Okay, each box has a location here, and the location of the next box is written here. Okay, so that you can traverse in this way in each boxes. So the representation is in this form. You will use a structure. In structure you can store the information and the next pointer. Okay, so you are using a pointer here to point to the next box memory location. Okay, so int info and struct node star next. So this is the pointer pointing to the next location. See, there are few basic facts. If you remember that, you can write the code in your own way, because there are more than like 30 codes, and it's not practical to memorize all of those, and you might get confused because most of the codes are similar, but just 1-2 lines are different. So coming to here, I'll be telling you the basic things, and then you can write your code in your own, but I'll be explaining each code also in case you feel any difficulty. See here, you will have 4 types of linked list. First one is singly, doubly, circular singly and circular doubly. Okay, let's discuss one by one. First one is singly linked list. In this, as the name suggests, what it does is it will point to the single node, single next node. Okay, so suppose that this is the node, it will point to the next node here, and this will point to the next node. If it's not pointing to any more node, this will be stored as null. Okay, and the first node will be always pointed by header. Header is nothing but it will just have a location of this node, first node. Okay, it will not have any information part, it will just have the location. That is known as a header node. Now in this way it is the structure is defined. It's same int info and star next in singly linked list. The first operation is create node. Understand this carefully. You can use this same code for all of those type of linked list. See here, in create node what you will do, you will create a node. Okay, how you will do that? First you will write temp is equal to this malloc size of struct node. Means what is happening, malloc, as I have told earlier, malloc means it will allocate the memory for a node. Okay, so how much memory is to be allocated, that is determined by size of struct node. So that struct node has some size, right? That much size memory will be allocated, and that will be named as temp. Okay, means that memory location will be pointed to by temp. Okay, struct node, so this is the format you have to write. After allocating that much memory, what you will do, printf enter the info. Info means you need to get the information part here, so you will scanf the information part and store it here. Okay, you will use like this, temp arrow info. So in the temp arrow info part you will have the number which the user enters. Next, temp arrow next is equal to null. Since you just have the one character here, means one node here, you will have the next location as null, means it's not pointing to any more location. That's the way to create a node. Next, what you will do, insertion at the beginning. Okay, means what, if in case first is null, means there is no node. If there is no node, this is the first node, that will be pointed by first and last. This is the first and last node. Okay, in case if there are many more nodes, what will happen, see here, these are many nodes here. Okay, means this is pointing to this. What I have to do, insert this at first location. So how I will do that, firstly I will edit this. See here, create, I will create this node. Okay, then after that, temp arrow next is equal to first. Since this is the first node, next part of this should be pointing to the now which first node is there, means this will point to this, right? So in the memory, so in the address part I have to store this address which is 1000, that I will store here instead of null 1000. How will this be done in the form of a code? Temp arrow next is equal to first. What is first? First is having the address of this, so 1000. 1000 should be stored in temp arrow next. This is temp arrow next, this part temp arrow next, this will have the location of this, and then you have to make the first is equal to temp, means temp's memory location which is 500, that will be stored in first. Okay, so when that will be stored in first, that means this will be pointing to this first node. Since temp is the first node, now it will not point to this, it will point to this. Okay, and this connection is also made. That's the way to insert the node at beginning. For all the questions, whatever they ask, if they ask at end, you have to keep this here, draw image and keep this here and see what changes you have to make. Like null should be pointing to the memory location of this, and first will be pointing to this, last will be pointing to this. You have to change. Let's discuss all of them. See, insertion at end. If first is equal to null, then you will just allocate a memory location and you will make it point to the first and last. First will also be pointing to this and last will also be pointing to this. Okay, that's the if first is null, means there is no node. And if there is a node here, see there is a list here. Okay, what you will do, you this is the normal list. First is this, last node is this. These both are connected. What your task is, it is our task is to create a new node and insert at end. This is the end, right? If you have to insert this node at here, what changes start to be happened? This null is here, right? That null should have the memory address of this, because temp is the last node now, so it will be connected to this. This has 500, so here it will be stored as 500. After that, last should be changed. Last will be pointing to this location now, 500. So 500 will be stored. First will have no change. Okay, so in this way, if you type 500 here, this will be pointing to this, and this is inserted at the last. So that's what the code is here. Last arrow next, this is last arrow next, that is equal to, see, last is pointing to this. What it is pointing to, it was pointing to this, right? 2000 initially. Last arrow next means 2000's arrow next. This part should have temp. Temp means 500. That will have 500 here, so the connection will be made here, and last is equal to temp. So last should have the address of temp, so that last will be pointing to the last node, which is temp here. Okay, for all the types of linked list, you will have the display function as same. See here, while temp is not equal to null, you will initialize a variable temp. Okay, that will be pointing to the first location. While temp is not equal to null, what you will do, first you will point to this and print this 5. Printf temp arrow info, which is 5, that will be printed. Then next, temp is equal to temp arrow next. Temp is equal to temp arrow next. What is temp arrow next? 100. So temp will be 100 now, so temp will come here. Okay, see, this is the 100th memory location, so temp will come here. This will be printed. Then temp will go here. This will be printed. After that, when temp goes here, temp arrow next will be null. So temp will be pointing to null. When temp is null, this will be coming out of this loop. Okay, so all that elements will be printed till then. The next is delete a node at the beginning. Okay, see, if temp arrow next is equal to null, means only there is one node. See here, if I have to delete node, only one node is here. This is the temp. Okay, only one node is here. If I have to delete this, what I will do, if temp arrow next is equal to null, so I will check if the next location is empty, that means only one node is there. I will free temp, means this memory location will be free and this will be deleted. In case if there are many more nodes here, in this case, what I will do, see here, first is equal to temp arrow next. First is this, it's pointing to this. First is equal to temp arrow next. The first line is first is equal to temp arrow next. What is temp arrow next? This is temp arrow next is this 100. So first will have 100. What does that mean? Now first will be pointing to this memory location, and free temp means this memory location will be free now, so the list will be starting from here and the first node is deleted. Okay, the next is deletion at the end, means rear end. Okay, how you will do that? First you will go to the last location where you have to delete. Okay, and then you will delete it. See, while temp arrow next is not equal to null, means the last location will only have the next location as null, right? So temp arrow next is not equal to null. Till that time you have to traverse, like temp is equal to temp arrow next. First what will happen, temp will be here, temp is equal to temp arrow next. This will go here, means temp arrow next is 100, so temp will become 100 and it will point here. Then temp will become 200, it will point here. Then temp will become null. Temp will become null. Before that you will free the temp here. Okay, because while temp arrow next is not equal to null, this should traverse. If temp arrow next is equal to null, it will not traverse, it will stay at this position and you will use free temp to delete this node. So at the end the node is deleted. Doubly linked list is also the same as the previous one. It will have all those functions which were there in that, but just one difference is that you have to, doubly linked list, you will have two arrows. Okay, first will be pointing to the next location, and even in this node you will have the location for the previous one. Okay, so that is doubly linked list. The structure definition is the same, but you will have a link for the previous node also. Okay, so previous info and next node. Okay, now the functions are everything same. For every function you will use temp arrow previous as extra line of code in doubly linked list. Okay, see, the first one is insertion at the beginning. It's the same. You will have the if first is null, you will have no node. Then you will create and assign the first and last to temp. Okay, so you will create a node and assign the first and last to temp, and you will assign this as null, the previous arrow and the next arrow as null, because only one node is there. In case if you have two nodes, what you will do? See, in this case, what you have to do? If this node is here, okay, first what you will do? Temp arrow next is equal to first, means this one, this will be pointing to this one, and first arrow priv, first is pointing to this, arrow priv means this one should have temp, so it will point to temp here, and then first is equal to temp, this is the first node, so first should be pointing to temp, so first arrow temp will be making this first to point to temp. Okay, so the first will be having 400 here. In this way you will insert the first node in beginning of a linked list. For insertion at the end, you will do the same thing. If the first is null, you will create and assign first and last to the temp. Else what you will do, see, make this drawing, it will be very easy. Then you have these nodes. Okay, suppose you have to insert this node, what changes you have to make? You have to make this point to this and this point to this. What is this here? Last arrow next, right? So first is last arrow next. Last arrow next is equal to temp, and in temp arrow priv, that is equal to last, right? So this will point to this, and since last node is this, now last will be pointed to temp, so temp is equal to last. For all programs you try this way, you can write the code from your own. In display function it's the same thing, no difference here. See, you will start from this temp, you will go to the next node, and you will go to the next node until temp arrow temp is not equal to null. When temp becomes null, that means it has reached the end of the list. Deleting the for deleting the node from the beginning, you will have three cases here. If first is null, that means the list is empty. If first arrow next is null, that means only one node is there. Then free first, that will deallocate this memory, and else, see, if many nodes are there, what you will do? You will make this first to point to this one, that means first is equal to first arrow next, so first will go here, first will be pointing to here, and free temp. Okay, you will deallocate this memory, so list will be this. You have deleted the first node here. For deleting at the rear end, what you will do? See, since we have this previous here, what we can do? Temp is equal to last arrow priv. Last is pointing to this last location, and last arrow priv is this one, right? So temp will be pointing to here. Okay, temp will be pointing to here. Temp arrow next is equal to null, so temp arrow next will become null, and free last means this memory will be deallocated. So the list is this now. Circular singly linked list, only the difference is the last node will be pointed to the first node here. Okay, before it was pointing to null, right? In circular it will point to the first node. The representation is same, and insertion at the beginning, it's all same, just you have to keep in mind that see, if you are trying to make this insert at the beginning, what you will do? First you will make this point to this one, and the last will be pointed to this temp. Okay, see, you will allocate this memory and you will make an temp node. Then after that, if last is equal to null, means last is equal to temp. If last is null, means there is no node, means only one node is there. Else temp arrow next is equal to last arrow next. What does that mean? What is last arrow next? Last arrow next is 100. Okay, means this one, this location you got 100, that is in temp arrow next. Temp arrow next is this should point to 100. So you will point to the first node in the temp, and then last arrow next is equal to temp. What is last arrow next? This one, this should have the value of temp, because it's the last node, it should point to the first node here. This is the first node here, right? This connection has been made by this statement, and this connection will be made by this statement. Okay, suppose that I had to insert this node at the last. Okay, so what I will do first, temp arrow next, which is this one, that should be last arrow next. Last is this, last arrow next will give me the location of the first, so this will be pointing to the first location. In circular linked list, last will be pointing to the first location, right? So I'll make this connection first, then last arrow next is equal to temp. Last is this, right? This arrow next means this one, this should be pointing to temp, so by this temp will be pointed by last here. Okay, so then at last I forgot to write here, last will become temp, so last is equal to temp. What it will do, last will be pointing to this one here. Okay, means last will be 300 now. Display function is the same. Suppose you have many nodes here, and you will just keep on displaying it until it reaches the first node again. Okay, let's look logically what can happen in deletion at beginning. See, suppose this is the list, okay, deletion at beginning means this node should be deleted. If this node is deleted, what changes will happen? This one will be pointing to this one, okay. So where will I get this location? This will be present in first arrow next, okay. So what is this? This is last arrow next. So first line will be first is equal to last arrow next, okay. So first will point to last arrow next, okay. Then last arrow next is equal to first arrow next. What is last arrow next? This one. This one is equal to first arrow next, means first is pointing to this, right? First arrow next is 200, so this will be pointing to 200 here. All right. If we were to delete the last node here, what changes will happen? See, this is the last node then. So how will I get this location? Previous is equal to last arrow next. By that I'll get the first location here, okay. See, last arrow next, this is pointing to the first node, so I'll get the first node location in previous. While previous arrow next is not equal to last, means I'll travel until previous arrow next, means this part previous arrow next is not equal to last. What is last? 400. So I will travel first here and check if this is 400, if this is 400. If this is 400, previous will be pointing to here. At that time previous arrow next is last, so this is the second last node. At that time when I get this, what I will do? Previous arrow next is equal to last arrow next. Previous arrow next is in this position. What should be stored? Last arrow next. What is last arrow next? Last arrow next is 100, which is the first location. So what I am doing, I am cut shorting this to first location here, and I'll free last at the end, okay. So in that way, this is the linked list here left. See, basically header node is also a node just like this, but it will not have an information here. And the first node is not a header node. First node is always this one, okay. And header node will be pointing to this one. But last node will not point to first node. It will point to header node. These are the two things which you need to keep in mind for header node, okay. Now insertion at beginning. Let's see one of this. If this is the header node, okay, and I have to insert at the beginning. This is the first node. This should be the first node now. Initially this is the first node. If I have to insert this here, what I'll do, I'll make this point to this and I'll make the next point to this. How will do that? Temp arrow next is equal to head arrow next. What is temp arrow next? Temp arrow next is this. That should be equal to head arrow next. What is head arrow next? 1000. So this location will be stored here, 1000, okay. So when this location is stored here, I have to make the connection from head to this, right? So head arrow next is equal to temp. That means this is head arrow next. What it should store? Next. Next is 200. So 200 will be stored here. Then this is the first node. Don't confuse this with the first node. This is the first node which is inserted at the beginning. List starts from here, okay. Inserting node at the end is also same. You'll have a temp here, and if you want to insert at the end, what you'll do, you'll make this point to this, and then this null will be pointed to head, okay. Let's see how it happens. First you will make current is equal to head arrow next, means first node. This is the first node. Current arrow next will make point to the first node. Current will have this node, okay. See, this is current. Then while current arrow next is not equal to head, means this is only having one node, so current arrow next is head. See, current arrow next is head, so it will come out of this, and current arrow next is equal to temp. So current arrow next, this point. See, current arrow next is this will point to this here, okay. So a connection will be made between these both, and next is temp arrow next is equal to head. So this part temp arrow next, which is temp arrow next here, that will be head. So this will be pointed to head here, okay. And deletion at rear end, that means you have to delete this node here, okay. In if you have to delete this node here, what you will do? First current is equal to head arrow next. Head arrow next is this, so current will be pointing here, okay. Then previous is equal to head. This is previous. Now what you will do, while current arrow next is not equal to head, means current arrow next is not equal to head, previous is equal to current, and current is equal to current arrow next. So previous is equal to current, means previous will also point to here, and current is equal to current arrow next, means this will point here. Then again it will check, while current arrow next is not equal to head, yes, current arrow next is head, so at that time it will come out of this loop, and previous arrow next is equal to head. So previous arrow next, which is this point, this will be equal to head, so this will be pointing to head, okay. So in that way I'll free current at last, and this will be deleted from the rear end. And deletion from front end is, if I have to delete this one, okay, from front end means this is the first node, this is not considered as first node, this is the first node. If I have to delete this, what I will do, first is equal to head arrow next. First head arrow next is this, so this will be first, okay. So this is first here, and second is equal to first arrow next, so this will be second. Now head arrow next is equal to second. Since I got the second location, head arrow next, this part should be pointing to second, so this will point to the second directly and this will be removed from here. I'll free first, so this memory will be deallocated. Okay, so you have deleted the first node. Then coming to circular doubly linked list, it is the same circular list, but it will have the previous location also here. Okay, so the implementation is in this way. Next location and previous location space will be there, and in between info will be there. And if you have to insert the node at the beginning, what you will do, temp is equal to, you will allocate a memory for the temp, and then you will assign the previous and the next location as temp only, because since you have only one node, right? So the previous location and the next location will be pointed to the same node. Then if you have to insert a node at the beginning, and there are many nodes here, okay, what changes have to happen here? See, first you will start from here. Last is equal to first arrow previous. Last is this one. Okay, last is this one. First arrow previous. What is first arrow previous? First arrow previous, this part is pointing to here, so last will be 300. Okay, then temp arrow next is equal to first, so temp arrow next is this should point to this, right? So it will make it will form a connection here, and then first arrow previous is equal to temp, this is first arrow previous, that will point to temp, so this connection is made here. In next two lines, what you will do, you will make the connection with the last. See, last arrow next means this one, last arrow next is this should point to the temp, so it will point to the temp here, and temp arrow previous is equal to last, this is temp arrow previous, it will point to the last. So in that way the connection is made between these all nodes, and this temp is inserted at the beginning. See, for insertion of a node at rear end, these are the allocations. Means first you will create a node and assign that as temp. If first is null, then return temp. Means if there is no node, you will just return that newly created node. Otherwise the main function starts from here in case many nodes are there. Okay, first one is last is equal to first arrow previous. See how you will get the last node here, first arrow previous, that will be pointing to the last node, right? Then you will get last as 200, and then last arrow next is equal to temp. Last arrow next, this part, this should point to temp, right? And this will be pointing to temp, and temp arrow previous is equal to last, so temp arrow previous is this will be pointing to the last, so this connection is made. Next connection you will make the next part of temp with the first arrow previous is equal to temp, so first arrow previous is this will be pointing to the temp here, and then temp arrow next is equal to first, temp arrow next is this will be pointing to first. Okay, in that way node will be inserted at the end of the list. Coming to delete node at the beginning, see delete node at the beginning means if this is the list, you have to delete this node. Okay, what changes will happen? Second is equal to first arrow next. Okay, this is first arrow next is this, so second will be pointing to this. Last is equal to first arrow previous, first arrow previous is this one, so you will get the last location here, and last will be 300 here. Now what you have to do, second arrow previous is equal to last will be stored in second arrow previous. What is second arrow previous? This one, so last will be stored here. So what does that mean? That means it will point directly to the last location. We are deleting this, right? So this will point to the last location here, and then last arrow next is equal to second, last arrow next is this one, this will point to second here. So in that way this connection and this connection is broken with the first, and I'll free first, so the linked list will be this here. I have deleted the first node from the beginning. Deleting a node from the rear end means I have to delete this node. Okay, for that what I have to do, what changes will be happening here, last is equal to first arrow previous, I'll get the last location by first arrow previous, and then temp is equal to last arrow previous. What is last arrow previous is this. Okay, so this is 200, which is this location, so I'll get the this node here. Okay, second last node. Then temp arrow next is equal to first, temp arrow next is this should point to the first here. Okay, I'll make a connection here, then first arrow previous is equal to temp, this will point to temp here. So in that way I have broken the connection from both the sides with this one, and I'll free last, and I have deleted the node from the rear end. This is the first node, second node. Okay, the first node is being pointed by header node. Okay, now this is the same implementation, and if you have to insert at the beginning, see always remember this is the first node here. If you have to insert this, you have to insert it here, not here. Okay, because head is not a node which is a part of the list, it is just pointing to the first node here. Okay, so if you have to insert this here, what you will do, you will use this head arrow next point to temp here, see, head arrow next will be pointed to temp here, and temp arrow previous, this is temp arrow previous, this will point to head here. Okay, then you have made this connection. Next you have to make this connection. How you will make? This is temp arrow next, temp arrow next is equal to first arrow previous is equal to temp. In that way you will create this chain of node. In case you have to insert the node from the rear end, what you will do, these are for the memory allocation, then the function starts from here. Last is equal to head arrow previous. See, this is last is equal to head arrow previous. Head is having the location of the previous node, which is the last node, right? See, head arrow previous will have the location of the last node, so you will get last as 300. This is the last node you will get. Then what you will do, last arrow next is equal to temp. Okay, last arrow next, what is last arrow next? This will have a connection with this, and then temp arrow previous is equal to last. See, temp arrow previous is equal to last, this will have this connection, and then temp arrow next should point to head, and then head arrow previous is should point to temp. Okay, so that's two codes here, and then you will make the last point to this. That's optional. If you want, you can make last point to this, or else you can just return head at last. And deleting a node from the front end, this is the first node, so you have to delete this node. Okay, remember, this is the header node, you will have to delete this node. If you have to delete this node, what you will do, you will make this connection with this and previous connection with this. Okay, so you will get the first node here. What you will do, head arrow next is equal to first arrow next. See, head arrow next is this. What it should have, it should have this address. Where you will get this address, this will be present in first arrow next here. So first arrow next will be pointed by head, so you'll write head arrow next is equal to first arrow next, so it will point here. And then what is this? This is second, means how you will get second, first arrow next, you will write second is equal to first arrow next. So second will be this, first arrow next 300, second will be pointing to this, then you will use this for pointing to head. Second arrow previous is equal to head. Deleting node from the rear end is also the same thing. See, just observe always what you are supposed to do. Draw a list, and if you have to delete this node, what you will do, this location should be pointed to head here, and this head's previous location should be pointed to here. That's what's happening in this code. And display is the same, you will use a node here, temp here, and you will point until the it reaches again to the header node. Okay, and you will not print the header node first, you will start from head arrow next. So this is the first node, right? So you start from head arrow next. Okay, so see here, current is equal to head arrow next, while current is not equal to head, means current will start from here, head arrow next, and it will go on, and it will again come back here. When it come back here, that means all the elements are printed, and that ends the program here. Stacks using linked list, this is the stack, right? If you have to represent this stack using a linked list, what you will do, you will make each location as a node. Okay, and it will be pointing to the next location here. Okay, that is stacks as a linked list. And queues also you will have the same thing, but in that you will have the front pointing to the first location and the rear pointing to the last location. Okay, and next is evaluation of polynomials. See, suppose the polynomial is this one. Okay, 5x cube y square z square plus 3y square plus 4x cube z. For each term will have one node. Okay, and in this nodes, what will be there, 5 will be stored in the first position, and in the second position the exponent of x will be stored 3, then exponent of y, then exponent of z. Okay, and this will have the location to point to the next term. Okay, this will have the address of the next node here, and this is the second term. See, only y square is here, so only the y square term will be 2, others will be 0. Similarly for this one also, and head will be pointing to the first starting term. Okay, see, initially this list is there. Now if you have to add another term like 3x square y square z, something you have to add at the last. How you will do that? You will insert a node at the rear end. Okay, let's see how it is in polynomials. For this you will have the CF, means coefficient, power of x, power of y, power of z, and head. Okay, suppose that CF is 3 and Px is 3, Py is 4 and Pz is 2. That means the polynomial term is 3x cube y4 z square. Okay, now you have to insert this. How you will do that? You will create a node and you will assign temp arrow CF, means coefficient part of the temp as 3. So this 3 will be coming here, 3 will be coming here, 4 will be coming here, and 2 will be coming here. This is the next location. Okay, now see, after you have assigned all of this, what you will do, current is equal to head arrow next. This is head arrow next is this, so current will be pointing to here, while current arrow next is not equal to head, means it reaches the last node. Only the last node will have the next part as head, right? See, this is the last node, it will have the location of next as head. So when you will make the current reach the last node, then you will point this current's next part to the temp and temp's next part to the head. Okay, in that way you will assign this. If this is the polynomial, at the last this temp will come here, and the temp will be inserted at this last, and a new term will be inserted at the end of this list. The next is to create a polynomial of n terms. Means there are many terms, like suppose you have to insert these terms. Suppose that you have to make a list of these 3 terms. Okay, so initially you will take the first term and ask the user to enter its coefficient. Before that you will ask how many terms are to be inserted. If here there are 3 terms to be inserted, so in the first you will make a for loop for I is equal to 1 till how many terms are to be inserted. Then you will ask the user for the coefficient, power of x and y and z. Okay, so user will be entering this coefficient and the powers. So here in this case it will be 3 here, 2, 2 and 0. Okay, for the first term. Now after that you will call this function insert rare. You remember in insert rare, if we have these functions here, see we had these functions, right, that will be called here, and by using these functions we can create a temp and assign it to the rare end. Okay, so this will be created, temp will be created, and 3x square y square will be added here. Next again it will go to the second iteration till I becomes n, means 3 terms. So it will again ask the user what are the terms. The second term is 4 z square, so coefficient will be 4 here now, and this will be 0, and this will be 2 here. So according to this another term will be created and this will be assigned here. Okay, so in that way all the codes will be assigned, and at last 2x is there, so 2x code will be assigned here, 2x node will be assigned here, and in that way you can read the polynomial consisting of n terms. Okay, so playing the polynomial, what you will have, you will start from here. Temp is equal to head arrow next. Suppose that the polynomial here is this, it is stored in the form of linked list in this way. Okay, then temp will be pointing to head arrow next. This is the head arrow next is this. Okay, head arrow next, so this is temp here. Okay, now what you will do, you will check if temp arrow cf is less than 0. Temp arrow cf is 3, it's not less than 0, else printf plus percentage d. What will percentage d have? Temp arrow cf plus 3 will be printed, and then temp if temp arrow px is not equal to 0, means temp arrow px is this point 1, it is 1, it's not 0, so printf x raised to percentage d. What is percentage d? Temp arrow px, which is 1, so how it will be printed? X raised to 1. Okay, then it will check if y is also, if exponent of y is not 0, then it will be printed as y arrow 1. Okay, then z is also not 0, so z arrow 1, like that it will print here. Then temp will be shifted to the next location. Temp is equal to temp arrow next, temp will go here, then it will check again, temp arrow temp is not equal to head, temp is not equal to head, so it will print here percentage d temp arrow cf. So temp arrow cf is 4, so plus 4 will be printed, and then temp arrow px will be checked, it's not 0, so it will be printed x raised to 2, then y raised to 2, and z is 0, right? See, temp arrow pz is 0, so this will not be executed, and it will just end here, and temp will go to the next location. What is the next location for this? Temp arrow next is pointing to head, so temp will be pointing to head now. Okay, so it will check here, while temp is not equal to head, then only it should be executed. Since temp is head now, it will stop the execution, and till then the polynomial would have been printed here. First consider the following matrix. It has 5 rows and 4 columns. Okay, and count the number of non-zero elements. 1 2 3 4 5 6 6 non-zero elements are there. So first step, what you have to do, you have to make a head node here. Okay, how you will do that? Divide into 2 sections and make 3 columns here up. Okay, and here you will write the number of rows here, which is 5. Then you will write the number of columns, and you will write the number of non-zero elements. Now what you have to do, for each column, see, column 0 to column 3, you have to make a connection like this. Okay, see, make a box here and divide it into 2 columns and write here c of 0. Okay, like that you have to do for all the rows. After you are done for all of this, then you have to make the same for the rows here. Okay, after making the rows and the columns, what you have to do, you have to look at the matrix and see the first non-zero element. Start from here, this is the first non-zero element, which is this row, 0th row, 0th row and the 0th column, right? So in the 0th row and the 0th column you have to make a box here. Okay, you will make a box like this and divide it into 2 sections, and you will make 3 columns here. In that, what you will write, the row number, the column number, and the value. Okay, then find the next element here, which is 5. 5 will be here. Okay, for that again you have to search, and then you have to search the next non-zero element and make it accordingly. After making for all non-zero elements, observe here carefully what you have to do. See, make this column, okay, make this box point to this, and from here you have to point to the next column. Okay, after having done this, what you have to do, make this as a dotted line here. Okay, this as a dotted line here till last. Okay, after doing till here, it has no more here, so what you will do, you will make this point to the column. Okay, like this, like that you have to do for all. After having done for all non-zero elements, see which column has no element, you will make this point to itself. Okay, similarly you will do for the rows also. In rows you will point this to the next one. Okay, like this, this will be pointed to this row, and this will be pointed to this row, and this is the representation of sparse matrix.